Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop as promised. A quick look at the component finished up in the last video. All the holes are tapped, all the edges are broken. And for anyone wondering, there's a spot in the center that just didn't lap out, but that's not a problem. For anyone wondering how the half bearing was going to stay put, there is a hole in the bottom of the bearing cap. So the end journals will slide on the crankshaft. This one will be in place. Everything will drop in. Then it will be trapped in the center and screwed down. Let's see how close you got to being on center. Not bad for working blind. Pretty close to being in the dead center of that web. And I'm sure that's the way it was intended. Anyway, the next piece of line are the units that go in here, the main bearings themselves. And they're made out of these guys right here. This is the material I showed you in the previous video. Does fit real nice in here. Now ideally you want a congruent fit. You want it to be in contact all the way around so that any crank pressure doesn't blow this apart, doesn't crack it. You'd like it to be supported. Ideally you'd like it to be supported. This material is called out as brass, and you know, from where I'm sitting, it's got that kind of rosy pink color to it. And I got to tell you, I think this is more bronze than brass. And being said, when you sand this material, make sure you wear an appropriate respirator, because some of this is just no bueno for going up your nose. So don't do it. Okay, put a little dust mask on if you're gonna sand it with any type of aggression. Keep that from happening. Stay healthy, all right? Some of these materials will come and get you, especially if you grind it. Supposedly grinding bronze, phosphor bronze, is not a good idea. The parts are relatively simple. Just like anything else, it's going to be tougher to hold them than to actually machine them. Two of the small ones, and they strike again, right? One part number. This 18 is the little pin up at the top that holds the center cap in place. But you would think it's like, right? 3 views. No, wrong. One piece, a second different piece, a view of that piece. So beware of what you're looking at. Don't scratch your head too much. You'll get down to the skin and you'll be bald, so don't do that. I'm going to go on with 1838s. I'm going to start with, it's going to be a flip-flop operation. I will probably try to establish a parallel back to the underside of the flange here so that I can then trap this and dust that off, make that nice and clean. But you can't do that if you can't trust the back. So you can't trust the back if you can't register off of these two surfaces. What came first, the chicken or the egg, right? This is one of those one of those times. Let's get out in the shop, do some measurements, push this thing up against the sander, see what we got to start with, make some chips. Now let's take a look at the logic I'm going to use to straighten these things out. I know that there is a couple thousandths worth of clearance between net-shaped casting that you have right now and the detail that they told you to put in the base. What I would love to do, coming straight off the grinder, or the belt sander, I'm about 457 and change right there, and right on the end, 457 and change as well. So I know right across the center here is true, and that this is flat because I put it on the block and I rocked it, or tried to, and it didn't. That being said, any deviation in the ears out here could be warpage in the ear, it could be anything. So you just can't trust the outside surfaces here. When it goes back in the mill now, I'm going to press it against the stationary jaw this way, that way. And I'm going to rest the parallel under here. not registering in that corner because that corner still isn't dead sharp. The distance from this underside flat to the center of this round feature here is 1/8 of an inch, so I know that anywhere in this area, general vicinity area right here, should be fine to keep it parallel. I mic'd it. These are all true within a 1/2 thousandth, which is really good. So by banking here, I can dust this surface and that surface back there. Same thing when I flip it over. Ideally, I would like to get them both the same, but don't know if that's a good idea. There's a 5 thousandths difference in the thickness of these two pieces, and if I thin this one out too much, well then this surface here drops too far into the journal and it'll rock when you try to tighten it, and probably crack when you go to tighten it. So let's not do that. I'm going to treat them as individuals. The only thing that's going to do, since this is inverted when it's installed, you'll need a little bit longer screw to get through there by what, 1/10 of a millimeter. Let's go to the hardware store and order up a couple of those. The guy's going to throw you out in the street. All right, let's get over to the mill, make a very delicate setup, and dust off these faces right here, just enough to clean them up and sharpen this inside corner right there. With the bottoms of these castings nice and flat to my satisfaction, I'm going to stand them up in the vise in this particular setup, and you can see how I got the parallels spaced out so the parallel is not close to the inside rib. I know there's a flat section right here, so that's what I'm going to be banking on. And my intention is to get these back ears straight and squared off to the body. I know I'm not going to do it on the side of the vise, I'm going to do it in the center, but right here in this area is where I'll be working. I want to just barely touch the side, and I definitely want to clean this up, but I don't want to exceed the height from here to the top of the radius, because then it'll be longer than the journal cut in the base. So this has got to be very superficial, and I'm going to lock the table, remove the piece, rotate the piece, and do each side at the same time. So I'm going to take one cut, take the piece out, flip it, do another cut without moving anything on the machine except the table. So the height will be set, the y-axis will be set, I'll just be dusting with the X. Let's do it. Using the same setup, I will now cut the outside edges to bring this thing into parallel. The way the part is now configured, you have parallel ears on this guy, symmetrical about the center line, and if there's any discrepancy in the overall heights of the parts, well, now you have a nice banking surface that you can lay them in here and you can deck this off if you so desire. I guess just for sake of continuity, next step in line will be to do the ends, and then we'll figure out how we're going to put all the holes in. Going to deburr both sides, flip it around using the stop, bring both the blanks to the same length. Now for anybody that's going to question the setup, the other piece is in the other side of the vise, stabilizing the jaw so the thing closes parallel. You don't want to hang on to one piece out here without something on the other side of the similar size. All right. Just like any project, you have to pause once in a while and take a real hard look before you take your next step. If there's anything nagging at the back of you that says check it out, then stop and check it out, because that's time to stop and check it out. We have two pieces here, two of these, one of these, but this one here, the longer one, is two pieces. What does that mean? Well, that means if you expect it to look like this when you're done, you're going to have to use like a magic wand or something to cut this thing in half, because you're going to lose the height, and God knows what's going to happen to this when it gets in the model. Well, when I'm done cutting this and putting it back together, I want it to look exactly like it does now, which means I'm going to have to make a top and I'm going to have to make a bottom, because there's no way to do that from this particular casting. You just can't do it. Upon further inspection, I can tell that there's one piece that's going to have to be 781, the other one's going to be 594. Let's just wing it. Do that. And this is the way that I'm going to divide this material. I'm going to make one of the 594s on each end and one of the 781s on the opposite side. So this will be the 781 top, this will be the 781 bottom. Easily accomplished. Once I pop the hole in there, if I can do that for you. There you go, magic. Boom, it's got a hole in it. I'm going to keep these together as long as I can keep them together. I'm going to put all the holes in them. I'm not going to put the screw holes in until they're completely cut off. But here we go. Once the holes are in, I'm going to mill away half with one. I'm going to take this and make this all go away. That'll be the top. And on this one, I will mill away the opposite. And knowing what the stack height is, I will use the one as I mill the other, and I will just continue to mill it down until I get back to my original solid block stack height. So that's the plan. When I bank these, I'm going to bank these in a very unusual manner. I'm going to make a vertical nest for it. I'm going to register on the inside right here, because that is the banking surface. This has nothing to do with the function of this part. This could be a mile thick, it could be paper thin. This is the working surface right there. That's what you need to pay attention to. And the fixture that I'm going to use is not going to allow this to move under pressure for any purpose. And I think you're going to like what you see there. I'll demonstrate that as well. All right, let's go make a small block. I'll tell you the why, make the how. The slot in this particular block is just about 1/1000th or so, not even, bigger than the width of that boss. So I've accomplished two things with this style of fixture. I've located on the critical surface, which is the underside of the cap, to establish a center line for the journal hole, and I've centered the part. If I wanted to, all I need to do right now is rotate this part vertically, and I have my center line because I know what it said on the digital. But unfortunately, I'm going to flip this part so the slot is facing me, the operator, that side. I'll true it up with a 1, 2, 3 block and indicate the center, and we can go from there. Boy, that is a highly reflective surface, right? Look at that. There you go. That's a little closer. This gives me the opportunity to flip the part around as I see fit, because I'm going to do this 50-50. I'm not going to bore this all the way through. I could, but I'm not going to. The line bore operation that many of you have suggested or recommended, I like that idea. It would make for a very true journal setup, but then the journals would be specific to the seat in the block that they're assigned to. I'm going to try to make these universal so we can put them anywhere we want. Let me deburr this inside corner here on both sides on the top, just in case the cutter had a radius on it. I want to make sure that this is not interfering with the part itself. Be right back. Okay guys, here's a shop gem for you, something for you to remember. I'm putting the block in the vise. Remember that, there will be a quiz. Anyway, watch the indicator. The part is now snug. It is very snug. I'm going to crank down on the handle. Watch the indicator move. Now this is a 675 Kurt vise, and it is not abused at all, so there's nothing wrong with the vise. Watch the needle. And I've really torqued on that. Picked up about 1,002/10. Now, if you're doing a very critical part, or you're doing a part from end to end, and you have a mismatch of 1,000th on either end because of inconsistent torque on your vise, well, you're going to be struggling with that most of the day. And back to zero. Part comes out. In a setup like this, zoom out here for a second. In a setup like this that I'm going to use for the journal, if I could find them, here we go, right in front of my face. The part's going to be standing up like this, and I'm going to put a clamp across it this way. By applying pressure from both sides, the forces are going to cancel each other out, and that center line is going to stay true to the world indefinitely. This block is not going to move the way you just saw that indicator move when I squeezed the vise. So the initial setup, I will tighten the vise. I will not unloosen the vise until I am done with the parts. I'm going to use a 1, 2, 3 block to set this vertically, and then I will sweep this with the indicator, edge finder against this, and I will have the spot where I need to make these pieces work. And set this way, I can put a parallel under here where my middle finger is to set the height, should I need to. All right, let's do it. The x-axis is now centered with the slot. I'll pick an edge finder up, pick up this face right here, and move in 1/8 of an inch. That is a calculated move based on the print, believing that the flanges on the journals are 1/8 of an inch thick. So they wanted 1/4 of an inch from the back surface if these were 1/8 of an inch, but they are not. So I'm moving in 1/8 from the inside surface. I'm going to rough bore these and then finish bore these, and as I explained before, we have one long and one short coming out of each piece. So the depth for each operation, there'll be two that are the same from the long side, and then I'll choke up on the setup, two that are shorter from the opposite side. First stage of the boring operation is to rough them all to the same size, and I'm going to go 50-50 on the block. I'm going to go halfway in from this side, flip it halfway in from the other side on both blocks, and then I will do the final sizing, but I'll get within 5 thou for the final pass. I'm going to mark which side needs to be the long side and the short side, and finish bore these to just about 1,000th over the crank rod that needs to go through there. 282 is the imperial size I'm going to go for. 282. For the final boring operation, once the boring bar is set to the correct diameter, I am not going to move the head for the next piece. It's going to stay as is. The load on the tool is really light. There's only about a 5,000ths left coming out of there to clean this up to a finish size. So deflection should not be an issue. Once I got it dialed in, that's it. Leave it alone. Just reverse the pieces as needed and adjust your depth. And I've learned from experience, if one side of the pin doesn't go, try the other side. You never know if the last guy in line dropped it, dinged it, whatever. That's a heck of a way to find out that your hole has been on size and you just keep on going. I want about 1,000th clearance here. Now, if you build this engine and these are oversized, chances are you're going to get a little knocking sound coming out of here, so fit it however you like it. And if it knocks, use thicker oil. Next operation, I'm going to have to make one piece like this, but it's going to have a top and a bottom because it's a center journal on the crank and you can't slide it over the two throws, one to either side. So what I've got here, the part is pressed securely against the back jaw. The camera is positioned on the left side of the vise. That's left side. I have indicated the pin, and knowing the diameter of the cutter I'm going to be using, I will be stepping half the diameter of the cutter off for the cap. I will step off in the back, and you're just going to see a remaining C shape that's divided right on the parting line of the pin. And then for the base, or actually which is the cap, I will step the cutter off the other way and finish up with a flat with a couple of round ears, or a couple of straight ears with the round feature in the center. It's going to be a lot easier to understand once you start seeing it happen. But knowing the diameter of your cutter is important, and being on center for the initial operation is important. And this part is presented vertically, and there's enough space between this surface and here for the final saw cut and finishing operation when this is complete. I hope that makes sense because that's the plan and I hope it works, so let's do it. That is the lower half of the cap. And I will now use this as a gauge for the stack height when I do the other side. And you can see the shape currently trapped in the vise. That is the shape that's going to be proud when I jump to the other side and remove this material on the next piece. You can see the ridge on the inside where the boring bar stopped. That is right on the split line. So if I split that part right on there, right on the bandsaw, that'll be the bottom. That'll be the top. That's a tough camera angle. There we go. Bottom, top. Two pieces. Next step in the process to complete these parts is to put the two round journals on the end. Now they are asymmetric. One is 156 or 532 long. The other one is 1/8 of an inch. This is going to go on an expansion arbor in the lathe, and this should be relatively quick. Let's go over to the lathe, make it happen. The final turning on this expansion arbor is done with this screw under pressure, so these fingers are expanded. When I unloosen the screw, the fingers will collapse. Normally there's an undercut where the cut on where the slots terminate, but this is so small and delicate that if I were to do that, it would probably blow up under the final turning. The back dimension, the back diameter, is the solid diameter for establishing the concentricity of the features, and the front is for grip. Try not to ever take your slit all the way. You won't be able to trust the concentricity of a setup like this. Let me put the camera on a tripod and we'll cut these up. I'm going to turn the short side first, and that is always a good idea if you have the option. In case you go over your required dimension, part is still good. You can just make it the long side. See what happens. The interruption is going to give it an unfair influence off center like that, so unless you're turning a hex or a square, the interruption being intermittent like that is going to have quite an influence. Be real careful and take little steps. And for those of you typing away right now, yes, you could have milled these ears down to a square profile and you'd have a lot less of this interruption to be concerned about. All the other journals will be cut exactly the same way. There's no sense in showing it in redundant steps. I'll cut the other 4. We'll cut the other 3 ends, and we'll go and look on that bench. Take a look. It is hard to tell, but these are asymmetric. This one is about 3/4 of a millimeter longer than this side. I guess when I point it out, you can see it. The mounting holes are not in yet, and this one will be done in the fixture that I used to bore them all, and I'll just put a reverse boring bar in it and interpolate that. I'll actually reverse bore the diameter on there, and I'll do it to match this one right here. It'll be a whole lot easier to keep it clean that way. Let's take a look at the installation. At assembly, there'll be a pin there that matches up with this that will keep this guy from migrating back and forth. That is complete. And as I sit here, I'm not sure if the long side goes in or not, but right now it doesn't matter because they're universal. You can swap them once the holes are drilled. Let's trap that down the center, give you a look at the assembly. Going to put a little bit of pressure on here just to mimic it being seated. And this slides just ever so beautifully. I'm really pleased with that. I'll set these up and drill these down the road. No sense in showing in this video, but I accomplished what I wanted to accomplish. There you go. Thank you very much for spending part of your day with me wherever you are in the world. I hope you're well and happy and safe, all the above. I'm Joe Pye here at Advanced Innovations in Austin, Texas. I'm out.